Hello everybody and welcome to another edition of Square Root Academy Tech Tutorials. Today we're going to show you how to use a piezoelectric speaker, an LED, and a button, all for one project powered by the Arduino Uno. So this is going to be the first of two videos that is going to show you how to make a piano using the Arduino, but for now we're going to start off with just one button. Alright, let's get to it. So you're going to need the following materials: an Arduino Uno, a breadboard, 7 wires of varying lengths as seen in the photo here, a button, a 10K ohm resistor as well as a 220 ohm resistor, an LED, which is short for light emitting diode. It's pretty much just like a little tiny light bulb. And finally, the piezoelectric speaker. Now once we've got all of those in order, let's get to the wiring portion. Like any electronics project, you're going to go ahead and need to power it. So we're going to take a wire from the 5-volt terminal on the Arduino Uno, and then take that wire and plug it into the positive row on the breadboard. In order to complete the circuit, we're now going to plug in another wire from the ground port in the Arduino Uno, and then take that and plug it into the negative portion right here. As you see, my mouse is circling around it. Plug it in right there, right next to the positive wire. So now we're going to get into the communication portion of it. So you're going to take a wire and connect it to pin A5, so that's going to be analog input, and then we're going to connect that to pin J8 on the breadboard. And for the digital portion, you're going to take a wire and connect it to 5 on the microprocessor. It's going to have the tilde in front of it, which is the little squiggly looking thing. And then you're going to take that same wire and plug it all the way over here to J16 on the breadboard. Alright, so now that we've gotten that done, let's move on to the button. So the button is going to control the flow of electricity. It's going to allow electricity to flow or not flow depending on how it's coded. For our project, we're going to have the buttons in terminal F6, F8, E6, as well as E8. Now that that button is in there nice and secure, we want to go ahead and give it some power. So you're going to take a wire and plug it right here, and then take it to A6 on the breadboard. And now for the negatively charged aspect of it, you're going to take that 10K resistor and then plug it into B8 and have the other end plugged into B12. After that, you're going to take another wire, plug it into A12 and then to the negative row on the same breadboard. Now that we've finished the button portion, let's go ahead and look into that LED portion and getting that set up. So we couldn't exactly get the LED to show how we wanted it to show on the schematic that we developed here, but have no fear, we're going to take care of you. So plug in the positive portion of the LED, which is going to be the slightly longer wire. We're going to get that plugged into H16 for the positive, and then for the negative, which would be the slightly shorter, we're going to have that plugged into H19. And now you're going to take your piezoelectric speaker, and you see how it has the little plus right there on top of it? So that's going to be your positive leg of it. So you're going to take that positive leg and plug it into L16, and then have the negative one plugged into L19. After that, we're going to take our 220 ohm resistor that we have here and plug it into I19 on one end and I23 on the other end. And for the final step, what you're going to want to do is take a wire and plug it into H23, and then take the other end of it and have it plugged in anywhere along that negatively charged row. Any row, any port will do. Alright, and that should do it. That completes our circuit, the wiring portion of it. So let's get into the programming. Okay, so you're going to want to go ahead and open your Arduino software up. And once you get that up and running, your initial screen should look something like this here. Notice you should have the void setup and then the void loop portions in there. But prior to that, we want to go ahead and define a few things. So we're going to define our speaker, our LED, and our button. So just above the void setup, we called out the LED red, const int LED red equals 5. We chose 5 because of, you remember the digital 5 we put in there? That's how we're going to commute to the LED as well as our speaker. So we set that LED red equal to 5, and then const int red speaker is what we're calling our speaker for our red LED. We're going to have that equal to 5 so we can control them both from that particular input or output. The button, however, is a little bit different. If you recall, we had that plugged into our analog, which you can look at if you assembled your circuit right in front of you. So our button is going to be controlled by that A5 analog output. After doing that, under the void setup portion on your screen, we're going to want to do is make sure that we're defining whether these are outputs or inputs. So technically, once we press this button, what we want is for a light, the LED red, to come on, and we also want the speaker. We want both of those to produce an output, whereas the button is going to produce an input. So we're going to have those defined as pin mode, parentheses, LED red, comma, outputs, and then below that, pin mode, red speaker, output. Then below that, pin mode, red button, input. So right below where we define those pin modes, outside of the bracket just below it, we're going to want to go ahead and define our initial state. So in order to do that, our initial is going to be red button state equals low. So the choices are high and low. High and coding is like on, and low is going to be off. So when we first plug everything in and get it going, we don't want the light to be going just yet until we press the button. The next thing we're going to do is we're going to go ahead and use our digital read command. And what that allows us to do is read states. So just as earlier we did int red state equals low, what that's going to do is allow us to read that. So we're going to define red button state equals digital read in parentheses red button. Now we're going to introduce something. It's a little bit more trickier of a concept to understand. It's the if-else function. So it's almost what it sounds like. If this condition happens, then this other thing happens. That would be how you explain the if portion. Now the else portion would be if this if thing isn't happening, then this other thing is happening, which would be the else portion. However, it's defined in the lines following the else statement in the code. Alright, so for our case, if red button state equals high, we want the digital write for the LED red to be high, so therefore the LED light will be on. And now we're going to have a function called tone. So this is another thing that's new for us. What tone allows us to do is it allows us to communicate with our piezoelectric speaker. So depending on the number, we're using 1200, that's going to determine the frequency, which is going to be how deep or how high the noise is or sound. And then we're also going to want to have a little delay there. So once we press the button, it hold the note for a little bit longer depending on if we want our delay higher or lower. The lower it is, the shorter amount of time it's going to hold the note, and the higher the number is, the longer it's going to hold the note after we release the button. Okay, now that we have the if portion in there, let's go ahead and get that else portion. So if that initial condition of red button state equaling high isn't met, then we're going to have to write digital write LED equals low, which means our LED will be off and there will be no tone. Hope you enjoyed this other rendition of Square Root Academy Tech Tutorials. Catch us next time where we'll be defining how to do more of these buttons on there and make an actual Arduino powered piano. See you then. Happy coding.